Okay, this is problem 6-9. Alright, first thing you want to do on this problem here is take a moment, either A or B. I'll go ahead and take a moment at A. Before I do that, I'll draw my quick free body diagram. So, what happened here, you'd have a beam coming up here. You'd have this B reacting here coming up. You'd most likely have A reacting coming up here. I'll draw that straighter. Like that, and you could put this one here. We can tell looking at this force here is going to be 0. So then we'll label this FBY. This will be FAY. Here you have a distributed load going all the way across the beam, so we can basically say, just turn that into one single force coming down here in the middle of this beam. This beam is 6 long, so we know the distance from here to here is going to be 3, and the distance from here to here is going to be 4. Alright, we can go ahead and find out with calculation this. This is 6 kilonewtons per meter, so this is 6. That's going to give me a value of 36 kilonewtons. Again, all I'm doing is I have it's just a rectangular load, so I just multiply it by the distance times the height, and that's going to give me the force here of 36 kilonewtons. Alright, and this point here is A. So with some or moments around A, we will get 36 kilonewtons times this distance, moment arm, and the distance will be 3. We'll make that negative since it's going this direction here, plus FBY times 4. We'll solve for FBY in this case. FBY will get 27 kilonewtons coming up. And then all we have to do is sum our forces in the Y. Set that equal to 0. We'll have negative 36 kilonewtons coming down, plus the 27 we just figured out. Oops, do that again, sorry. Plus the 27 we just found coming here, plus FAY equal to 0, and we'll get FAY will equal to 9 kilonewtons, and that's going up here. Alright, and again, if you sum the forces of the x, this is the only x you have, so this one right now has got to be 0. Okay, so now we have that, and we can go ahead and draw our shear diagram just based upon that information. So to draw a shear diagram, we'll draw a straight line. Okay, the first thing we do, we're going to go up 9. We'll go ahead and put our 9 value right here. Okay, kilonewtons. And what you want to do now is you want to go all the way over to B, because this load is going to decrease going down, and it's going to, the value is going to increase, but as you go over all the way over here. So you want to come over to 4. So we'll put a dot here approximately at 4, and we're going to find out what the value here would be. So if we take 6 times 4, we're going to get 24. So between here and here, we need to go down 24. So 24 minus 9 gives me a value of 15. So I would come down 15 down to here. And what you have, this is a linear relationship between here and here, so this is going to drop here. And then we can label this value here as negative 15 coming down. Okay, once you hit that, then you're going to apply what the load is at B. And we said B was 27. So we're going to go back up 27. Minus 15 plus 27 gives me a value of 12. So I'll just draw this up here like this. Draw that straighter line. And you don't have to use arrows if you don't want to. So as we said, this value would be the 12 here. And then all that's going to do is that's going to decrease a linear relationship between here and go back to 0. And if you find the area of this distance here, you know this is 6 from here to here, and 6 times 2 is 12, and that's why it goes back. So that's what your shear diagram is going to look like. Alright, so now that since you have the shear, there's two areas you need to look at. You look at where it crosses. You know it crosses here and here. This one we know where it is. We know that from here, draw this all the way down, from here to here, this distance is going to be 4. We need to find out where this distance is. It's really not as bad as it looks. We just need to find out where we had 9 and where this area here is going to equal to 9 too. So I'll just kind of write the equation. We could say that 9 is going up, and then minus this value here is, scroll up, so this value here is 6. So we could say minus 6 times x is equal to 0. Move that to the other side, we get minus 6x is equal to minus 9. X is equal to 9 over 6. Value here. Divide that by 3, and that's going to give me a value of 1.5. So that what we did was we know this distance from here to here to be 1.5. Alright, so there's your shear diagram. Now let's draw the moment one. It's not going to be bad at all. And the best thing really would be to come straight down. I'm not necessarily going to do that. I'm just going to draw this like this. We're going to put our critical points would be, I'm going to find this one here. We'll do that in red. And we'll do one here, 4. So the areas we're going to be looking at right now would be coming over 1.5 and then coming over the value of 4. So let's do it this way. I'll put a 4 here and a 1.5 because the moment diagram is probably going to get down in those areas here. Alright, so let's first thing is do and figure out how much moment we have here, and we can start drawing this. So if I was going to find the moment, we'll call this, you can call it C, we can call it anything you want. We'll call it the 1.5 point. If I do that, I have 9 coming up, going the other way. I'll get 9 times 1.5. Okay, and then minus, we said the value is going to be 6. So that would be 6 times 1.5 times its moment arm, which will be half of 1.5, or 0.75. Like that. We'll run that value here. So what is 9 times 1.5 minus 6 times 1.5 times 0.75? That gives us a value of 6.75. Okay, now the only thing is you need to think about shape. This will start here, and your area here is decreasing as you go over. Since it's decreasing, the slope has to be decreasing. This thing's going to do something kind of like this. It's going to flatten out here because that has to be 0 here. That's going to be a max. Now we'll do what the moment is going to be at 4, and if we sum the moments at 4, we will get 9 times 1.5 minus the 6 times the 4 times this moment arm, which will be 2. We'll add that value there. 9 times 1.5. Oh, sorry. I'll make that 4. My fault. Change that very quickly. I apologize. That should be 4 right there. Okay, do it again. Here we go. 9 times 4 minus 6 times 4 times 2. That gives me a value of minus 12. So we'd come down here, and then this value here we could label as the minus 12. I should be labeling this as I go to. This is 6.75. So again, what's taking place here, go back to calculus, is this area is increasing from a negative, so my slope has to be decreasing. Just something kind of like that. Not a very good curve. Let's do that better than that. Kind of like this. Not very good. All right. Now what was taking place here, I'm going to be going back up here, but my slope is going to be decreasing, so this has to be something kind of like that. And that's my moment diagram. And really that's all there is to it. Your maximum moment would be -12 here. You had 6.75 here. So if you're looking for the failure mode where this object would fail as a result of moment, it would be right here at 4. All right.